Right, welcome to today's set 0, and we're going to be concentrating on vectors today. And without further ado, we're going to just warm up with nice easy questions. It should only take you about 30 seconds. It's just to check you remember the things you need to remember, and we'll go through it very quickly afterwards. So here we go, 30 seconds first. Right, so if you're a little bit rusty on vectors questions, the key things to doing these questions is to find pathways around using what you are given. So OA from here to here will give defined as A, and OB is defined as B. So we also know it's a parallelogram, so therefore this is the center. Okay, and the diagonals intersect and cut each other in half. So this will also be B this way, and this will also be A that way, looking at that. So to find in terms of B, the vector dB, so we want to go from D to B, we can see we need 2B. Now, the textbook's bold, write in bold for vectors. We can't write in bold, so we underline our vectors. Now, find in terms of A and B the vector AB. So we want to get from A to B, but we can't go directly there. We have to use the things we know, and we're going to go in the opposite direction of A, so that's minus A plus B. But I'm going to write it as B minus A. So if you take it in order of the vectors you're going to use, you'd write minus A plus B. As mathematicians, we tend to put the minus in the middle. Find in terms of A and B the vector AD. So we're going to go from here to here. So we're going to go minus A minus B. A to D. Just want to check that because I had a different answer earlier. No, it is the answer I had. I'm just checking my answer I wrote down. And you get minus A minus B. Right, just checking how long I think. I suggested 60 seconds. Actually going to give you 2 minutes because I think you should have a bit of reading and thinking time for the next question. So here we go, 2 minutes, next question. Okay, so we've stepped up a little bit. We're going to show that AB is parallel to MN. And what you need to do to show if two vectors are parallel is you need to show that one is a multiple of another. So we're going to find MN to start off with. And MN, when you're doing this, if you want to go from N to N, what we need to do, if we want to go via O, you might like to think of it as MOON. And if it's going in the opposite direction, then it's going to be a negative. So MN, one way to help you do these roots round is to make sure these letters match up when adding them in sequence. Because when you're adding vectors, you add them in sequence on top of each other, on end, on end, on end. So MO, which is in the opposite direction to OM, is therefore minus M. And we're going to add on ON, which is just N. So we've now found MN. Now we want to find AB. Now we know that M is the midpoint of OA. So if that's the midpoint OA and this is M, then this distance from M to A will also be M, and the distance from here will also be N. So therefore AB will be equal to AO plus OB, and AO is equal to minus 2M, and OB is equal to 2N. And what we can see quite clearly here, that AB is equal to 2 lots of MN, therefore they are parallel. Okay. Right, again, we're going to step up the difficulty level. Next question. We're going to have 3 minutes for you to do this question. So off you go. Right, okay, so a nice easy start. Find the vector PB in terms of A and B. So we know that AB is equal to A, we know AN is equal to 2B, and we know NP is equal to B. So therefore this is going to be 3B, and this is going to be A. So therefore PB, we're going to go in the opposite direction, so it's going to be minus 3B plus A. We probably ought to write that as A minus 3B. Now we want, that's the easy part of the question. Now we want to show that NMC is a straight line. So we're going to go from here to here to here and show that it's a straight line. Now previously we were showing two things are parallel. To show if two things are parallel, we show one's a multiple of the other. To show something's on a straight line in vectors, what you need to do is you need to first of all show they're parallel, i.e. it's a multiple, but also one vector must, each of the two vectors you're showing are multiples of each other must contain one point. And if they both come from the same point and they're parallel, then obviously they must be on the same line. So let's go about doing that. So first of all, we're going to try and find NM. Is our starting point. So to find NM, we want to go from the easiest way, because we found PB, is we're going to go from N to P and then P to M, because we know that M is the midpoint of PB, so therefore it's going to be half of PB. So NM will equal NP plus a half, that's meant to be a plus sign there, P to M. Okay, notice the P's matching up in the middle again. So NM, NP is equal to B, and we want not half PM, sorry about that, apologies, that's a half PB. Okay, because half PB gives us PM. So we want that, and we want a half of this. Put the bracket in the wrong place, apologies. A half A minus 3B. So let's simplify that. So we're going to get a half of A, and then we're going to take 1.5 lots of B away from B, so it's going to give me a half of B. Now we want to find NC. So remember I said I wanted to contain one of the points. We could find MC, or we could find NC, but I prefer to find NC in this case. So I'm going to find NC because it's nice and easy. I'm going to do 2B, and it's going to be minus 2B plus 2 lots of A, because B is in the midpoint of, I think we said it somewhere, where we got AB, AB, B, B, B. B is the midpoint of AC. There we go. So we can use that to say that that's 2A. We can't assume anything. It has to be given to us, or we've got to prove it. You can't just assume that something's in the midpoint just because it looks like it's in the midpoint. You either have to prove it or it has to be stated in the question. So we rewrite that in order just to make it easier to visualize what's going on. And you notice that this is 4 times this. And I've forgotten my minus sign. That's 2 mistakes in one question. Going well. So this one is going to be 4 times that. So therefore, NC is equal to 4 times N of M. Therefore, what we've got, NMC is a straight line. And you might see this as written in some questions as show that they are collinear. Collinear also means they're all on the same straight line. Right. Hope you enjoyed that one. Next one, we're going to give you 5 minutes to have a go at on the next question. So here we go. If you've managed to finish this a little bit early, you can always get stuck into the next question if you've downloaded the OneNote, because it is quite a toughie. Okay, here we go. So this one was a little bit trickier than the last one. So we're told that OAN, OMB are straight, and APB are all straight lines. AN is equal to 2 lots of OA. So there we go. We've got something where this is 2 lots of that, and yet it doesn't look it in the diagram. So see, remember about saying that it's be careful not to assume anything. M is the midpoint of OB. OA equals A, so let's draw that little A in on there, and OB is equal to B, so let's put that little B on there just to remind us where they are. And we know that AP is equal to a multiple of AB, where K is the scalar quantity. Given MPN, so MPN is a straight line, we want to find the value of K. Okay, so we know that AP equals KAB, AP equals KAB, so we want to find out how far along this is. So what we're going to do is we're going to use the fact that MPN is a straight line. So first thing I'm going to do is find MP, and then I'm going to find MN and see what I get and see how that helps me. Now MP is going to be the same as M to O to A to P. O to A plus A to P. And we know that that is equal to minus a half B plus A. And we know that AP is K lots of AB. So let's just work with what, and it's not always obvious. It's not always obvious where we're going to go with this and what's going to happen. So just write down the things you do know. We know that MP and N are on the same line. So let's find MP and find MN and see what happens and see if something jumps out of us. Now we want K lots of AB. Now A is equal to minus A and OB is equal to B. So it's going to be minus A plus B for the AB bit, and K is obviously the multiple that takes us to AP. Now let's find MN. So we're going to go from here to here. So it's going to gain B minus a half B. And what I could, let's just write that down, minus half B, it's nice and simple. And now we know that AN, where was it? It was 2 lots of OA. So we're going to get plus 3A here, because this is 2 lots of A added onto 1 lot gives me 3 lots of A. Now we know that I'm going to say, because it's on a straight line, then I'm going to say something times by MN must be equal to MP. Right? This must be a multiple of this. Alright, or this must be a multiple of this. It doesn't really matter which way around you do it. You could put the lambda on this side, it wouldn't matter. This is just one way of doing it. So if we know that this is true, then what we can do is we know that lambda lots of MN, so lambda lots of this, will equal this. So let's just look at the B bits. Okay, let's just look at the B bits. So if I times the B bits here, I've got minus a half lambda. So I'm just going to look at the parts for B. All right, because I've got to make them equal. All right, and I've got minus a half B plus K lots of B over there. So it's minus a half plus K lots over there. All right, so what I've done is I've taken all the B bits. I'm just going to highlight them in yellow. Okay, there's the B bit, there's the B bit there, and here's the B bit here. Okay, and I've just made all the b bits must be equal. Now I don't need to have the b's in here. I could write them there. I could write a b there and a b there, but I just need the coefficients to be equal, all right, in this case, for this equation to be true. And we know this is true because they lie in a straight line. Now we're going to look at the a parts. So let's look at the a parts. I'm just going to highlight the a parts. So I've got 3 lots of a, I've got an a there, and I've got a k times minus a there. So I've got 3 will equal, sorry, not 3, because I've got to times it by lambda, remember, and lambda times that. So I've got 3 lambda will equal 1 lot of a minus k lots of a. So I've got 2 simultaneous equations here. I've got that and I've got that. And if I call this equation 1 and call this equation 2 and add them together, you can see the k minus k's will cancel. So what I'm going to do is I'm going to do equation 1 plus equation 2. So I'm going to get minus a half lambda plus 3 lambda, which gives me 2.5 lambda. And I get minus a half plus 1, which equals a half. So therefore, lambda must equal 1/5. And if lambda equals 1/5, we can put that back in to find out what k is. So therefore, we put it back into here, we get 3/5, take the k to this side, take it away from that side, I get k is equal to 2/5. And that's my final answer. But I might want to just check, I haven't made a mistake, because it's quite a complicated question. So let's put the lambda 1/5 into here. So I'm going to get minus 1/10, I'm going to get plus a half, add that on, I get 4/10, which is 2/5 as well from this one. So therefore it does work. So there we go, k equals 2/5. Now, if you can do the questions so far from 1 to 4, you can handle anything that GCSE level maths will throw at you up to grade 9. Okay, this next question is a little bit trickier, and you would not really see anything this hard on the GCSE paper. So, without further ado, I'm going to give you 3 minutes to have a go at the first half of this question, and then we'll go through that, and then you can have a go at the second half. Right, I've just cheated a little bit here and drawn the diagram I'm going to use to explain what's going on. So what I've done is I've created myself an origin, I've created my point A and I've created my point B, and we know that A has position vector A, and we have B has position vector B, and C lies on AB, such that the ratio of A to C is P to 1. So another way we can look at this is the whole length is P plus 1. So A to C will be P over P plus 1 lots of AB. And we could also write this one as 1 over P plus 1 if you want to get this section. Okay, so we want to find the position vector of C. So OC will equal little a plus P over P plus 1 lots of AB. And we know that AB is going to be minus A plus B. So we're going to have P over P plus 1 lots of A. So it's going to be OA, which is minus A, plus the B. There we go. So we've got that. And now what we've got to do is try and show that this is exactly the same as that. So let's get... sorry, phone call coming through. Let's get this all in terms of the A's all together to start with. So what we've got 1 minus P lot over P plus 1 lots of A, and we've got a plus P over P plus 1 lots of B. What I've done here is you've got that minus there, so I've times this by that, taking that minus into here, so I get minus that lots of A, and then I've got an A here, so that's just one lot of A when you multiply it out. So that times that gives me that, and this times this gives me those two combined. And what I'm going to do is write this as a single fraction, so that's going to be P plus 1 over P plus 1. 1 is P plus 1 over P plus 1 is 1, minus P over P plus 1. I'm getting a common denominator here for that. And I'm just going to leave this bit here. And I'm going to get myself some more space. Just scroll down a little bit. Okay, so we take this away from this. The P is going to cancel. So we're just going to be left with 1 over P plus 1 lots of A plus. Now what I'm going to do is I'm going to take out the P plus 1 and imagine I'm timesing that by P lots of B. Okay, and you can see I've got a common factor of 1 over P plus 1. So I get 1 over P plus 1 lots of A, and then I've got P bit lots of B there to show what they want me to show. Right, on this next bit of the question, I've drawn a little diagram to help you if you've not seen three-dimensional vectors before, because we've got I, J and K, and basically what they mean is I means, if you've got 2I, it means we've got 2 in the direction of the x-axis. J means 3 in the direction of the y-axis. And K means we go, well actually it's minus, so we go 4 down in the direction of the z-axis. Okay, in 3 dimensions. So this one would be minus I, so it would go that way. And this one would be 4J, which go that way. And this would be 12K, which go that way. You do not actually need this axis to be able to do this question at all. You should be able to do it purely from the geometry and from knowing what you know about if it is going to lie on the y-axis. Those are my hints for you to have a go at this question. Anyway, just going to give you 3 minutes and then I'll let you into the answer. So 3 minutes to have a go at seeing if you can find the value of P from this when you know that A and B equal these two values. Some of you may find it easier to write A as a column vector. So it's the vector 2, 3, minus 4. And B as a column vector minus 6, 4, 12. There's another way you can write these vectors. You don't have to write them in i's, j's and k's. I much prefer working with column vectors. Right. Okay. We've halved the numbers of the people in the lesson since starting this question. So it's obviously proven to be a bit too much for one or two. But anyway, we'll soldier on. So we know that C is equal to this, and we know that C lies on the y-axis. Now, if it lies on the y-axis, that means the x section and the z section are 0. So the x section and the z section is 0. So let's find out. Let's try and write out what we think C is. Well, C is 1 over P plus 1 times A plus PB. So let's just write 1 over P plus 1. And then we've got A. And A is 2, 3, and minus 4. And we've got P lots of B. So let's add on P lots of B. So P lots of that actually is going to be a minus. So let's just change that sign to a minus. So minus P times 6P, because P times 6 is the same as 6 times P, plus 4P plus 12P. Now we know that the component in the x direction is 0, and we also know the component in the z direction is 0. So we can solve either of these equals 0. Now we times it by 1 over P plus 1. Now what I've done when I've previously done it, I've written that 0 is equal to 1 over P plus 1 times 2 minus 6P and solved it for the x. But actually, what I should have realised is this is the denominator of my fraction. For a fraction to be equal to 0, it's just this bit that has to equal 0, just the top half, the 2 minus 6P. So all I need to realise is 2 minus 6P equals 0, and life is easy. And this can actually lead to a bit of confusion. So P equals 1/3. Okay, and we can just check that in the bottom one. If we notice, if we make that equal to 0, we can see that P is also going to equal 1/3, because 12P will equal 4. Divide by 12, you get 1/3. So both of these agree with each other. Therefore, C will be equal to 0 and 0 at the top and bottom, just like we expected. And we're going to make P equal to 1/3, so we're going to get 1 divided by 4/3, which is 3/4, times by what we got here. We got 4/3 plus 3/3, that's 13/3. So therefore, we're going to get C is equal to 13 over 4, 0. Or if you like to write it in IJK terms, C will just equal 13 over 4K. We don't need to write the I's and the J's because they're both equal to 0. All right. So that's the last question for today. What I'm going to do is I'm just going to create in the OneNote the extension section. What I will do is I will put in the answers to last week at the end of this lesson. I'm just going to grab you the questions so you can see them for today. And where are they? Here they are. I'm just going to get hold of them and show you so you have a quick preview of what today's this week's extension questions. A shout out to Yashwant last week for getting them all right. Let's just insert today's date. Where are we? Where's the date? Bang. Just inserting today's date into there. So send those through to myself or Mr. Saeed and let us know how you've done. Well done to Yashwant, who nailed every single question from last week. And well done to all the others who sent their answers in to us too. I'll also add in last week's answers to this section called extension in the OneNote, so you can then download them and check your answers. Anyway, look forward to seeing you all next week.